Looking at our comparison formula, we can know that the amplitude of this equation is 2. Because the period is 2 pi over b, and the b in this equation is 2, the period is just pi. Because the interval is equal to the period over 4, and the period is pi, the interval is just pi over 4. Because the phase shift is c over b, we divide negative pi over 8 by 2, and we're left with negative pi over 4. Last but not least, vertical shift is 1 because the vertical shift is just equal to d. Fill in the graph on the interval pi over 4. You're going to have 8 tick marks along the x-axis. Now begin to plot points based on your original equation without phase shifts or vertical shifts. Now begin to plot your graph again, but this time incorporating the phase shift, which is negative pi over 4. To do this, you're just going to move every point over negative pi over 4. The last step, which is your final graph, is going to be incorporating the vertical shift. Since the vertical shift is only 1, you're going to move every point from your last graph up 1 point. Cosine graphs are used in a variety of ways, mainly in STEM-related fields. They're used to chart the light spectrum, for measuring tsunamis and earthquakes, recording temperature fluctuations, and in the medical field to monitor heart rate and blood pressure.
Multiply both sides of the equation by 2. Simplify the fraction on the right side of the equation. Use the double angle formula to simplify the left side of the equation. Look for the two angles on the unit circle that equal the negative square root of 2 over 2. Write two new equations. Add the fractions with like denominators.
Solving trig equations can help mathematicians find the angle of a triangle. In real-life situations, meteorologists release weather balloons in order to measure the wind, temperature, and humidity. Knowing the rate that the balloon will rise per minute, calculations can be made about the balloon's movement. Measurements can be made to determine the angle from the ground to the balloon using the compass directions of north, south, and east and west.
These are the sum and difference formulas. Draw a triangle on a coordinate plane in quadrant 1. Because it is a side equation, label the side opposite the angle the numerator of the fraction and the hypotenuse the denominator of the fraction. Use the Pythagorean theorem to solve for the missing side. On a separate coordinate plane, draw a triangle in quadrant 2. Repeat the steps above to label the triangle. However, the missing angle will be negative. Use the sum and difference formula to find the cosine. Plug in the values and solve. Use the sum and difference formula to find the sine. Once you know the value of sine and cosine, you can solve for tangent. Divide sine over cosine to find the value of tangent.
What is going on? This is the same exact thing.
That can't be the first time this happened, right?
Yeah.
In class, students use the sum and difference formula to find the exact value of a trig function, which is the ratio of two lengths, and to simplify expressions to find identities. Sum and difference formulas are used in careers such as auto mechanics and aerial photography. Auto mechanics use the height of pistons to calculate when pistons will be at the same height. Also, aerial photographers use the tangent formula to calculate the ratio of the two lengths, the length of an image to the length of the physical object.
So to solve a dot product equation, there are two different formulas we can choose from. There's V1 plus V2 times W1 times W2, or the amplitude of V times the amplitude of W, all times the cosine of the angle, which is theta. So in this case, we're going to want to use V1 plus V2 times W1 plus W2 because we don't have the angle for the other formula. So now we're just setting up our equation and putting the correct values in place. So 1 plus 3 is 4, and 2 plus 4 is 6, so 4 times 6 is 24, and that is your dot product. A real-life example of when you would use dot product is when you're figuring out the total cost of a purchase when you go shopping. So you multiply the number of items times the price of each item, and you're going to get the dot product, or the total cost. In a law of cosines problem, you're given a triangle with only two sides and one angle. Because the triangle is not known to be a right triangle, the Pythagorean theorem doesn't apply. However, you can use a modified version of that theorem called the law of cosines. The first step in this problem is to write down all of the known variables like so. Next, begin to fill in the formula from before with those variables. Simplify the algebra and square root both sides of the equation to get the desired variable by itself. Plug in the information into a calculator to get your answer, which is approximately 20.87.
Each quadrant is numerically similar. If we take a look at quadrant 1, we can see that a 30-degree triangle, a 45-degree triangle, and a 60-degree triangle are created. At 30 degrees, the radian value is pi over 6. At 45, it is pi over 4, and at 60, it is pi over 3. The unit circle tells us the sine and the cosine of each triangle through the use of coordinates. At 30 degrees, the sine and cosine of the right triangle would be root 3 over 2, comma, 1/2. At 45, they would be root 2 over 2, comma, root 2 over 2. And at 60, they would be 1/2, comma, root 3 over 2. The first value, the x value, is the cosine, and the second value, the y value, is the sine. Through this, you can also find the tangent. Quadrant 2 is slightly different, but with the same intervals, and the sine is positive, but the cosine is negative. Here are the degrees and radians values of quadrant 3, with a negative sine and a negative cosine. These are the values for quadrant 4, which has a positive cosine and a negative sine. In quadrant 1, both the sine and the cosine are positive. In quadrant 2, the sine is positive and the cosine is negative. In quadrant 3, both the sine and the cosine are negative. And in quadrant 4, the sine is negative and the cosine is positive. The unit circle shows different types of trigonomic functions for various right triangles. It can be used in architecture and engineering. To solve a rotated conics problem, we must first identify the a, b, and c of the equation. In this equation, the a would be 2, the b would be root 3, and the c would be 1. We then apply these to the equation b squared minus 4ac to find the type of conic. Since this answer is negative, we know that this conic is an ellipse. Now we must find the angle of rotation. We plug in the a, b, and c to this formula here to find the angle of rotation. now know that the angle of rotation is 30 degrees. Now we substitute these equations for x and y in the original equation. We can use the angle of rotation that we found as theta. We then plug it into the equation with the values we get from the unit circle, and then FOIL. We then add like terms, and the x, y values should cancel. We then substitute these equations in for x and y, and using the angle of rotation that we found in the unit circle, we can find the exact values for these. We then substitute those into the equation, distribute, and then FOIL. Then we add like terms, and the x, y value should cancel, and what you are left with is an ellipse formula. To graph this, simply shift the x and y axes 30 degrees because that is the angle of rotation that we found. So the x-axis would rotate 30 degrees. So here's about 30 there, about 30 there, and the y-axis would rotate 30 degrees. We rotate it to the left because it is positive. Then simply graph your ellipse on that x and y axis instead of your normal one to get your rotated one. There it is. Rotating conics. Rotating conics are used in architecture and engineering.